Today we're going to look at the law of sines. It should be a review from Algebra 3-4. Thank you. Isaac, at the end of the period. You have a pass at the end of the period. You need to go someplace. That's you. Come get it. So this should be a review from the law of sines from last year. These should look familiar to you. Do they or do they not? Oh, have I not used this with you before? Oh, it's very fancy. The law of sines is used with any triangle. It doesn't have to be a right triangle. So the law of sines is used with any triangle to find missing sides or missing angles. You must have a side opposite an angle in order to use the law of sines. If you are given sides and angles where you don't have a side opposite an angle, you cannot use the law of sines. So if that happens, we'll go to law of cosines and we'll go over that next week. So let's look at example 1. And you don't really know what your triangle looks like when they give it to you. But this particular one, they've given you angle C, angle B, and side B. So you have angle B and the side opposite angle B. And so we're going to draw a sketch of our triangle. There you go. And I do know that I have an obtuse angle, so I'm going to draw my triangle so it looks like this. And so they gave me my obtuse angle is angle C, so I'll put that there. It doesn't really matter where you put B or the other angles A. So I'm going to put B and A here. So then labeling what they've given you. Angle C is 102.3 degrees. It's important that you draw a sketch of the triangle so that you can see what you have and what you still need to get. And then angle B is 28.7. And then opposite, side B is always opposite angle B. Side A is always opposite angle A, and side C is always opposite angle C. So you should know where those sides go. So since they gave me little side B, here's angle B, so side B is going to be across from angle B. Angles are always given capital letters, and sides are always given lowercase letters. So I know that side B is 27.4. There are 6 parts to any triangle, 3 angles and 3 sides. So when they say solve the triangle, they want you to find all 6 parts. So what would be the first part that would be the easiest to find given the information that you see in that picture?
The other angle.
The other angle. So that's the easiest thing. So let's find angle A. So in order to find angle A, what am I going to do? Add the 2 angles together and subtract them from 180. Yep, very good. So I'm going to add the 2 angles that I have been given, which would be 28. And if you can't read my writing up here, do let me know. I have horrible handwriting as it is, and to write with a stylist is very taxing. All right, so I want you to plug that in your calculator because I've already done it. So I want to see if you're plugging into your calculator correctly. Tell me what you get.
49.
And that is an exact value. 49 degrees is correct. If we have to round today, we are going to round to 2 decimal places, and you are never, ever, ever, ever going to round in the middle of a calculation. So the minute I get that answer, I'm going to update my picture. So I'm going to update my picture so that I know that I have 49 degrees. So now that I have all the angles, I can find any of the sides using law of sines. And it doesn't matter which of the proportions above you use. It makes no difference whether you put the sine on top or the sine on the bottom. But you have to maintain consistency. You cannot set up a proportion where you have the sine of A over side A equals side B over the sine of B. If you're going to put the sine up top, both ratios have to have the sine up top. If you're going to put the sine on the bottom, both ratios have to have the sine on the bottom. I prefer using sine on top of the fraction, so that's what I'm going to use. If you prefer to put it on the bottom, then you put it on the bottom. It doesn't matter. So at this point, the decision is, do I find side A, which is across from angle A, or do I find side C? It really doesn't matter which one. I tend to get in the habit of finding the largest angle and finding that side first. So I'm going to look for side C first. So find side C. So in order to do that, and for this particular example only, I'm going to set up the general equation that I'm using and then plug into it right next to it. So if I'm finding side C, I have to use a ratio where I have the angle and the side opposite it. So which angle do I have the side opposite it right now? B. So I have angle B and I have side B. So I have to use sine of B over side B as one of my ratios in my proportion. I have no choice. I can't use angle A over side A. I'm sorry, I can't use sine of A over side A equals sine of C over side C because I would have two unknowns in that ratio. So we're going to use sine of B over side B as one of our ratios. Equals, and then I want to find C, so I'm going to do sine of C over side C. And then I'm just going to plug in. So I'm going to move. I have no idea why it's not letting me move my paper. Weird. Let's try it again. Nope.
You're just trying to move it.
Yep.
Is that the
No, I don't know why it's doing that. Oh, that's fabulous. Oh, there we're back. I'm just not going to mess with it. All right. Never mind then. I'm just going to plug in and behave myself. So over here to the right, I'm going to try to squeeze it in so it won't let me move it. I'll have to figure out why it won't let me move it later. Okay. Yeah.
It's the same with kill trees.
Say that again.
It's the same with kill trees.
Well, see, there you go. You can look at it that way. I'm not killing trees. Oh, it still won't let me do it. All right, so sine of B, I know that B is 28.7 degrees, so I'm putting 28.7 in here, divided by side B, which is 27.4, equals sine of C. Well, I know. Okay, this is making me mad now. This is so annoying. Okay, there. I'll move that then. All right, so sine of C is 102.3. And then that's all divided by, do I know side C? Do I know side C? Nope. So it's just C. That's my one unknown. How do I solve a proportion? So we're going to cross multiply. So I have C times the sine of 28.7 equals 27.4 times the sine of 102.3. How am I going to solve for C? Well, I'm going to divide both sides because these are being multiplied, so undo it, don't I divide? So I'm going to divide this side by the sine. I haven't broken out my calculator yet, oh, by the way. So I'm going to divide that side by the sine of 28.7 and divide this side by the sine of 28.7. Don't those cancel? And then what you're going to put in your calculator is exactly what you see here, but you're going to end up rounding to two places. So I want you to take your calculator, make sure you check the mode right now. Check your mode on your calculator, make sure it's in what? No, what are we putting into the calculator? Degrees. So you want your mode to be in degrees. So when you put this into your calculator, you want to type in that 27.4 times the sine of 102.3 and that parentheses. And then you can hit division by this, or after here you can put an enter and then divide by the sine of 28.7. So you're going to test to see your knowledge to see if you can actually type this into your calculator correctly. Because if you go home and you don't know how to use your calculator, you're going to be lost. So type it in, tell me what you get. Isaac, type it in, tell me what you get.
1.46.
What'd you get?
5,501.46.
Does that seem unreasonable to you? 5,000?
Yeah, it does, but I don't know.
So let me, what did you do first?
I did. Oh, okay, I know what I did.
Did you find your error?
Yeah, I just plugged it in. Instead of 27.4, I put in 2007.
Ah, gotcha. Gotcha. So do stop and look for reasonableness, because that was a 5,000 would be a little unreasonable. So what else did we get? What did you get, Chasen?
55.75.
55.75 is correct. Oh, gracious. That was exciting. 55, let me write that nicer. Bless you. 55.75. That's rounded to two places, so that's why I have a squiggly equal. So there's 2 out of my 3. And I'm going to update my picture. So over here, I got 55.75. What's the only thing that's missing?
Side A.
Side A. We still have to apply the law of cosines. I can't use Pythagorean's theorem because the overall triangle is not a right triangle. So I still get to apply the law of cosines again. Why am I not going to use sine of angle B over side B as one of my ratios for finding side A? Why do I not want to use that? Why am I going to continue to use sine of, oh, did I say B?
Yeah,
Totally lied to you. I do want to use sine of B. Why?
Because that's
Because you already done.
That's the one I was given. I mean, technically, I could use sine of C over side C and still find side A, but why don't I want to use that?
The wrong choice.
I could have made an error in finding side C or an error in finding angle C. I don't know. Well, if I find an error in angle C, we're in trouble because they gave it to us, didn't they? So instead, I'm using the sine of B over side B, and I'm going to find side A. So let's plug in. So I've got sine of B. Well, B is 28.7 divided by side B, which is 27.4, equals the sine of C, I'm sorry, A, which is 49 degrees. This is why I write everything down. I'm old, I already forget it. Over, I don't know side A. So cross multiply to solve. We get A times the sine of 28.7 equals 27.4 times the sine of 49 degrees. Times the sine of 49 degrees. How do you solve? Divide both sides by the sine of 28.7, and that's what you're going to put in your calculator. So what does that equal?
43.06.
43.06 is correct. Anybody not get 43.06 so we can figure out where you went wrong? Are we good with that? If you don't have your calculator with you today, you need to go home and try these calculations and make sure that you're getting the correct answers before you go into Math Excel and do your homework. Because I'd hate for you to be getting them wrong on Math Excel because you're inputting into your calculator wrong, right? All right, so then really the proper way to write your solution is to write out all 6 parts. So your last step is to write out all 6 parts of that triangle. So we're just going to list them out. Angle A, and sometimes you have a squiggly equal, sometimes you have an exact equal sign. So if it's something that they gave you, which technically angle A is an equal sign because I used 2 known amounts to find that. So that one's not a squiggly equals. And then do use your degrees because it's your unit of measure. Angle B they gave you so it's exactly equal to 28.7. And angle C they gave you, which is 102.3 degrees. Side A we calculated, and that was approximately equal to 43.06. Side B, they gave you, so that's an exact value, so that should be a straight equals of 27.4. And side C we calculated, so that's a squiggly equals 55.75. So if they ask you to solve the triangle, this is the solution to solving that triangle. You have to include the three parts that they gave you. So that should be a review of what you did in 3-4 last year. True? Okay, what they probably didn't mention to you is the ambiguous case. And the ambiguous case comes from, so we're going to move to...
Yeah.
Okay, so we're going to look at the ambiguous case for law of sines. And just to recap what we did yesterday, law of sines can only be used if you have an angle and the side opposite the angle. If you don't have an angle and the side opposite the angle, we're going to be using law of cosines, which we'll do tomorrow. So yesterday you had two angles and a side. And so it was AAS, because you have to have the side opposite one of those angles. So it's not going to be ASA. So that was one case. This case is SSA, which is your bad word spelled backwards. For SSA, right? For SSA, you could actually have no solution, one solution, or two solutions. Two solutions meaning the three things they give you, the two sides and the angle that they give you, could create two different triangles. Or it could create one triangle, or it could create no triangle. So here, just for Star Wars fans, right? Here we have all the different possibilities. And I don't want to overwhelm you by looking at all of these. A is less than age, A is equal to age, A is greater than, all that kind of stuff. Don't worry about all this. It's really there to explain to you what it is you're actually finding. So if you're given two sides and an angle, here's what could happen. The angle that they give you, A, could be an acute angle. If it's an acute angle, it's possible that the side opposite is shorter than the side that's adjacent right here. And if that's the case, won't this kind of swing like a pendulum and never touch this other side? Will it ever make a triangle? Because this angle right here can change. So this is going to swing, and we're not going to make a triangle. That's a no solution. And I'm going to show you how to determine that by your math. But that's what a no solution looks like. It means two sides that aren't going to form a triangle. It's impossible because this angle can't change. These two sides can't change. The only thing that can change is this side here and that angle there, because those are the only missing pieces. Okay? Bless you. Or let's say that this side A is actually a little bit longer. Okay? It's long enough that it actually comes down and touches this side. Okay, so sorry for the interruption. So here, what if A is a little bit longer? If A is a little bit longer, it can actually make that triangle because this angle just got, smaller. And if that side is long enough, it'll eventually hit this side and make one triangle. Okay, so you can have one solution. So you can have no solution. You can have one solution. And this is just a different example where A is actually even longer and it just creates a wider angle here. So both of these are part of that one solution. So they're just different scenarios of what can happen when A is an acute angle. There's one more thing that can happen when A is an acute angle. If this angle is acute and the side opposite could either be, it could swing. So it's like this pendulum, but it swings so that it goes from here to here. In other words, this side here could either be this length or it could be all the way across here. And it's going to create this triangle here. You need to look up and watch me. I know. It's going to become important in a minute. And so it creates this triangle here where you have all three acute angles. Or it could actually swing down here and touch this third side a second time. So this side touches the third side twice. Once here, and it swings back around and it touches it once here. And what happens is this angle here is now an obtuse angle. So that was acute, it now becomes an obtuse angle. So you end up with this obtuse triangle or this acute triangle. This is a situation where you have two solutions, and that's the one that's harder to find. But I want you to understand why that is. This angle here and this angle here are going to be supplementary to each other. And that's going to become an important point in a minute. That's going to help you use the easier math. So I'm not going to teach you all of this garbage down here. We're not going to find all that. The only other thing that can happen is what if A is an obtuse angle? Only two things can occur. You can have no solution when they give you an obtuse angle, or you can just have one triangle. There's not going to be two triangles with an obtuse. It's not going to happen. So the only time you could have two solutions is if the angle that they give you is acute. Are you ready to go forth? You can't wait. So I'm going to erase that. All right, so then I'm not going to refer to this again. Hopefully not. So you've got that above. All right, so let's go ahead and look at, obviously I've got here single solution case where you're not going to know that right away. And in fact, given what they have here, you've got a side length of 22, a side length of 12, and you've got an angle 42 degrees. So we have an acute angle. It's possible with an acute angle you have no solution, one solution, two solutions, okay? You don't know until you do your first step. So I don't know if this triangle is going to be an overall acute triangle or an overall obtuse triangle or no triangle at all. So I'm just going to draw any triangle. I don't know what it is. I'm going to draw any triangle, and don't let it bother you if it doesn't work out. Now, I 100% of the time will put the angle that they give me, and in our notes, we always give you angle A. Well, they could give you angle B, they could give you angle C, so long as they give you the side across from that angle. So if they gave me A, I have to have side A. If they give you angle B, you have to have side B. If they give you angle C, you have to have side C. So whichever angle they give you, you're putting here. And then put your angle or your side opposite. So I've got my side opposite A is 22. The angle measure that they gave me was 42 degrees. And my writing gets successively worse when I have the stylus in my hand. Sorry. And then I like to put the second side that they give you that's not associated with your angle adjacent to it. So I'm going to put side B right here. If they gave you side C, I'd put side C there. So whatever other side they give you, I just always put it there. Just that way I don't have to think too much. And so that means this is angle B, and this must be angle C. And then this is going to be side C, equals. So all we have to find is two angles and a side. So our first step is going to be to use law of sines. And again, right now, I still don't know whether I have one solution, two solutions, or no solution. So we're going to use law of sines. Always, your first step on SSA is use law of sines. So I'm going to take always what they give me, the angle and the side opposite. That's going to be my full ratio. So I'm going to do sine of 42 degrees over 22. Sine of 42 degrees divided by 22. And that's going to equal, the only other side I have is side B, which is 12. So that's going to go in the denominator, and that means that I'm forced to find angle B. So I'm going to put sine of B up top over 12. Does anybody not understand how I set up that proportion? We're good with that. All from yesterday, right? So then we're just going to solve it. So we're going to cross multiply. I get 22 times the sine of B equals 12 times the sine of 42 degrees. How am I going to solve for sine of B? Divide by 22. So those cancel. And so what I have left is sine of B equals all of this. Here's the important thing. Whenever we're finding the missing angle, how do I put this in my calculator? I don't just put this in my calculator. I'm trying to find angle B. I use inverse sine, right? Remember the sine to the -1? Anytime you're missing your angle, in this case, I'm trying to find angle B. So if I'm trying to find the measure of angle B, I'm going to use the inverse sine on my calculator.
Is our calculator in
What are you putting in? She asked, is our calculator in radians or degrees? Am I putting radians or degrees into the calculator? Degrees. So we want our calculator in degree mode. So make sure that you do that. Do you want me to show you my calculator? Those of you who are sitting here? Okay, so I'm going to have the lights on. Elias, would you get the lights for me, or somebody? Those of you watching the video at home, you're not going to be able to see my calculator, ever so sorry. Oh, this will need this. So I'll just read to you what I've got on my calculator. Okay, because with the lights off, it confuses. It gets so confused. All right, so we're going to put into our calculator this inverse sine. You're making sure your calculator is in degrees, and I'm going to put exactly this in my calculator. 12 times the sine of 42 degrees. But remember, your calculator has parentheses here. You need to end the parentheses here after the 42. All divided by 22. Because if you don't end your parentheses after the 42 here, then your calculator is going to think it's going to take the sine of 42 divided by 22, and you're going to get the wrong answer. And so you're going to get, for the measure of angle B, approximately, so here we go on my calculator, second sine gets you that inverse sine of 12 times just the plain sine of 42 and that parentheses divided by 22 and the overall parentheses. And you get an actual answer. If this were a no solution, your calculator would say error. It'd give you some sort of error code. So because we get an actual value for the angle B, we get 21. We're going to round to 1 decimal place. So we get 21.4 degrees. So that is one of my solutions. So I'm going to put that what color? I'm going to put that in, oh, I don't know, green. So I'm going to put 21.4 here degrees. Oh, you can't see that. I'll move it over. You're done with my calculator, right? So there's 21.4. The problem is that that could be a reference angle. There could be, remember how I showed you how that side opposite angle A could swing like a pendulum and become an obtuse angle. So we have to look at its supplement also. But before we do that, let's find the missing angle here first, just to see if this is a viable triangle. So how do I find this missing angle here? Add these two and subtract them from 180 to get that one. So I'm going to take 180 and I'm going to subtract 42 and I'm going to subtract 21.4. And I get 116.6. Perfect. Whoops, I'm going to do it here. So I'm going to replace this with 116.6 degrees. So obviously I've drawn my triangle incorrectly. Shouldn't this be an obtuse triangle? Which is fine. Don't let that bother you if you drew your triangle incorrectly. How are we to know, right? However, angle B could be an obtuse angle because the 21.4 could be just our reference angle. So let's find the supplementary angle. So the supplementary angle equals, how are we going to find the supplementary angle to 21.4? Supplementary angles add up to 180, right? So we're going to take 180 and subtract 21.4. So 180 minus 21.4. We get 158, oopsies, 158.6 degrees. Now, just as an aside, if I were to draw a triangle with that in there, so here's my little triangle, here's my A, here's my B, C, this would be 158 now, 0.6. They originally gave me 42 degrees here, and then this side was 12, and this side was 22. Couldn't we now find this third missing angle? Don't we subtract these from 180? Let's see what happens. Marco, what's wrong? Don't we subtract those from 180?
No, I just quit on writing.
It's not
You can become ambidextrous. I have faith in you. So 180 minus 42 minus 158.6. What do you get? What value do you get when you do that? What'd you get? You do it. Don't make me do it. I already did it for my own purposes. What'd you get? Negative 20.6. Is there anything wrong with that? we can't have a negative value in the triangle, right? We can't have this. So that means there is no supplementary angle. It didn't work, right? Didn't it give you an invalid answer for the third angle in that triangle? Are you okay with that?
No.
Okay, so let's go back and look again.
Wait, I'm just confused. Like, I thought you already found the third angle.
We did. For using 21.4. So 21.4, when we put it here, we found the third angle, because remember, we don't know if there's one solution, two solutions, or no solutions. The fact that we got a solution tells us we have at least one solution. With the ambiguous case, SSA, you could have no solution, one solution, or two. The fact that we got an answer for B leaves us as one solution or two. Okay? So with the 21.4, you're right, we got the 116.6. That makes a triangle. Then you have to look at its supplement, because look at the picture above where it says 2, right? See how that side A can swing and make an acute triangle, overall acute triangle, or it swings to the left and makes an obtuse triangle. The supplement to 21.4 is an obtuse angle, 158.6. So I could put that in here. I know that it doesn't look obtuse. Don't let that bother you. If I add these together and subtract them from 180, it doesn't give us a reasonable answer for the third angle, right? That's why I know I have one solution and only one solution. So we're going to cross out this whole triangle. We crossed out the supplement, and we're only left with finding a side. Was there a question over here?
No, it was just the same question.
Did that make
Supplementary angle, yeah.
Did that make sense? Okay, because when your calculator finds the inverse of B, it's always finding a reference angle. It doesn't know that we could possibly have a supplementary angle that will work in this case and give us the same answer. Okay? Yes?
So when you do that, do you always use the angle you found? Subtract it from 180?
Yes, I use this angle here. Because if you look at the picture above, okay, because if I move this, all of my work does not move with it. I can try it, but I'll show you what I mean. Oh, it's working. Woohoo! Today it works. All right, so as you look up here, so the first one we found was this triangle, because the angle here was acute, right? That 21.4, that would go there, wouldn't it? With an acute angle here, I got 21.4 acute. Then this angle, for our purposes, turned out to be obtuse, right? Which worked. But this side can also swing, and because I can change this angle, because this angle is not set. Only that angle is set. So this side could swing and hit that third side here in two places. And it can create this obtuse angle. This angle here and this angle here are supplementary to each other. They just are. Trust me on that one. And so because of that, we have to evaluate the situation and see, could there be two solutions? So on here, when we went to look at the supplementary angle and we put it here instead of the other one, right? So we put the supplement here and we added those and subtracted them from 180, we got this negative value, which can't possibly work in a triangle. We can't have a negative angle. So that's how you know now it's only one solution. So we kicked out the no solution because we got a value for B. We kicked out the two solutions because we got a negative angle for that supplement.
So for every single problem, you have to choose.
Yes. Yes. Unless you get no, the only time you don't have to check the supplement is if you don't get a value for B because your calculator says it's an error. And then you know it's not going to even form a triangle. Okay? Elias, are you good? Okay.
If you do get an error, then the answer is just no solution.
Correct. Are there any other questions before we move on? Jesse, are you okay?
Well, it goes like that was like a part that I already understood. It's like
You did?
the time to rest.
Okay. I'm glad. I am so glad you took the time to rest.
Spread it out.
Spread it out. Okay, so we ready to move on? So that's our one solution. Then we're going to move on to no solution. Of course, you're not going to ever know that it's a no solution, but we know this time that it is. So do you need to see my calculator anymore? Do you trust me in putting it in? Okay. All right, so yes, that would be great, because then Jesse can rest again. Okay, so let's look at the no solution. Again, I don't know starting out what's going to happen. And the only time we have no solution, one solution, two solutions is when the given angle is acute. If the given angle is obtuse, it can be no solution or one solution. So you do have to kind of study those.
Here's a question.
Shelby?
How can we define
Oh, good question. We need to find side C. You're so correct. Thank you. See, I was worried about Jessie resting. Okay, so let's find side C. She's right. So then our step 2 was here. We were evaluating the supplementary angle. And Miss Murray forgot about step 3. Thank you. So step 3 is to find side C. Find side C. I'm glad you said something. All right, so our only missing part is that side. So again, we're going to use law of sines. And we're again going to use the ratio sine of 42 over 22 because that's our full ratio. But this time, because I have to find side C, I'm going to put the other ratio as sine of 116.6 over C. So we have sine of 42 degrees divided by 22 equals sine, oh, and I'm not going to be able to fit this one in, but I'll try, 116.6 degrees divided by C. So then we're just going to cross multiply and solve. We get C sine of 42 equals 22 sine of 116.6. How do we solve for C? So divide by sine, I'm going to squeeze it in here, 42. Divide all this by sine of 42. So that's what you're going to put in your calculator. You're going to put this in your calculator right here. Are we doing inverse sine this time? No, because we're finding C. It's not an angle. So then C is just 22. So 22 times the sine, plain sine of 116.6. If you hit enter, you get 19.67. And then divided by sine of 42, you get 29.4. And so that's our third piece, and we're going to throw that in here gently, 29.4. And then you want to look for reasonableness. Just amusing you all. Our smallest angle is 21.4. Is it across from the smallest side? Yes. Our medium angle is 42. Is it the middle side? And so that makes the 29.4 our largest. So our answer is reasonable. Yes.
What happens if we got all of the answers, but they don't make sense?
Then we had to have done something wrong in our calculation somewhere, and we want to go back and kind of look to see where might we be wrong, because the largest side must always be across from the largest angle. The smallest side has to be across from the smallest angle. So that's just your check to go back and go, okay, do I just trash everything that I did and start over? Or do I just look for my error? Because it could be maybe you put in your calculator wrong, or you just don't know, but that's a way to find out. All right, so any other questions? Good. Awesome. So let's move forth. All right, so let's move to the no solution case. So again, I don't know what kind of triangle I have, so I'm just drawing any old triangle. I have no idea if it's obtuse, acute, I don't know. So here's the angle that they gave me. I always put it on the lower left. Again, in our notes, we always give you A, but in your homework, you're going to be given angle B and side B. You're going to be given angle C and side C. It's not always angle A, so don't get used to always having angle A. Okay? So whatever angle they gave you, if they had given me angle B, I'd be putting B where I just put A. It's just, I just do it by habit. So angle A is 85 degrees. And then side A is 15. And so I always like to put the side that they gave me that doesn't have the angle adjacent to the angle they gave me. So side B is going to be here. And so that means that this is angle B and this is going to be angle C. So we're going to do the same thing we did before. Step 1, we're going to use the law of sines. It's always your first step. So sine of 85 over 15 equals, since we have side B, we're going to do sine of B over 25. Cross multiply, we get 15 sine of B equals 25. Sine of 85. How do I solve for sine of B? So divide by 15, divide by 15, and how am I putting this in my calculator? Yeah, so the measure of angle B is equal to the inverse sine of all of that, 25, whenever you're finding the angle measure. So whenever you're finding big A, big B, big C. So if you're finding a side length like we did on our third step before, notice we didn't do that. And in order to get rid of that trig function, you have to do the inverse. Think of it that way. If I want to get rid of that trig function sine, I get to do inverse sine or inverse cosine or whatever it is. So this time we have sine 85 divided by 15. When you put that into your calculator exactly as I have it here, what happens? You get a big old ugly error message. What error message did it give you? Domain error. Because what happens is, I believe if you find the decimal equivalency to this, it's like 4 point something. Remember when we do sine and cosine? You got to put in a number that's between -1 and 1, and that's the problem. So this ends up with an error, and since it's an error, this triangle is not possible, and it is a no solution. We love no solution problems because look how quick that one was, right? Okay. Now, two solution problems really aren't that much extra work. You might think that they are, but they're really not. They really create one extra step, and that's really it, one extra step. So again, I've been given two sides and an angle, and I have a side opposite my angle, so I can use law of sines. I don't know what type of triangle I have, so again, I'm just drawing my triangle. For the third time, you've been given angle A. I stress again, you're not always being given angle A. You could be given angle B or angle C, but you always have the side across from that angle. So whatever they give you, put it on the lower left. And then that is 20.5. And then the side opposite that, A, is 12. And then B, I want to put next door, adjacent, is 31. And then C. We good so far? What's my first step? Use law of sines. So very first step, sine of 20.5 divided by 12, the side opposite, equals, since I have side B, I'm going to do sine of B. Again, if they gave you side C, you'd be doing sine of C divided by 31. So we're going to solve for sine of B, cross multiply. So we get 12 sine of B, and you're going to run out of room on this one, so you want to write really small. 31 sine of 20.5. To solve for sine of B, don't I divide by 12? Right? 12s cancel. And if I want the measure of angle B, because that's what I'm solving for, to get rid of that sine part of the sine of B, what are we going to use? Inverse sine of 31 times the sine of 20.5, all divided by 12. And so the measure of angle B is approximately equal to, so you're going to hit inverse sine, so second sine, then 31 times the sine, regular sine, of 20.5. Make sure you close the parentheses at the end of 20.5, divided by 12 and close the overall parentheses. What'd you get? 64, round correctly, 64.8 degrees. So we actually got an answer. So do we have no solution? No. So we have a solution. So I'm going to put that answer here, 64.8. So this is a good answer choice, right? Let's finish off and find the value of angle C. To find the value of angle C, what am I going to do? Add these and subtract them from 180. So 180 minus 20.5 minus 64.8. Do we get a viable angle? Yep, I get 94.7. So there's my second piece. What's left? C. You want to go ahead and find side C or look to see if it has a second solution first? Have a side C and a second solution. It doesn't matter. So let's just look to see if there's a second solution, but some of us, like Mrs. Murray, would forget to find side C, right? So if we have a second solution, we need to find the supplements. We need to find the supplements to this angle that we found, right? So the supplements to angle B is equal to 180 minus the 64.8. And we get 115.2 degrees. So let's make up a secondary triangle. I took the 64.8 and subtracted it from 180 to get a supplement, right? And so that's how I got that. Make sense? So that 115.2 is going to go here. I realize I didn't draw it, so it looks obtuse. Don't let that bother you. That's our new angle B. Our old angle A is what they gave us, 20.5. Let's see what our new C would be. So aren't we going to take these, add them together, and subtract them from 180? So 180 minus the 20.5 minus the 115.2. Do we get a viable answer? Yes, we do. So we get 44.3. So that's how I know I have two solutions, is I got a second viable angle C from the supplement to angle B. Okay? So we can go ahead and find both side C's, but let me finish filling out my triangle. So on this new triangle, B is still 31 and A is still 12. That's an A. And then we're finding C and C. So let's do step 2 over here. Well, I guess technically it's step 3, isn't it? This was step 2 here, finding my supplement. So let's do step 3, find the side C to the first triangle. How are you going to do that? Law of sines, right? So start with the original angle A over side A. So sine of 20.5 divided by 12 equals right here.
Oh.
Got it?
Yeah.
Okay, and then I'm finding side C, so I want sine of, and I'm doing my first triangle, so I want the 94.7 because that's angle C. 94, I'm going to move this over, moving it over, there we go. 94.7 divided by C. So cross multiply, I get C times the sine of 20.5 equals, Connor, 12. I'm running out of room, so 12 sine of 94.7. How do you solve for C? Yeah, so C is equal to 12. Sine of 94.7. Come on. All divided by sine of 20.5. So when you put that in your calculator, what do you get? Is that what I really got? I don't know. Let's check it. So 12 times the sine of 94.7. If you hit equals, you get 11.96 divided by the sine of 20.5 gives you 34.2. Is that what you said?
Yeah.
Yep. So that's the last piece to the first triangle. You good with that? So just doing it one more piece, one more step for triangle 2. So then step 4 is to find C for triangle 2. So go through that same process. Sine of 20.5 divided by 12 equals the sine of, this time we're using 44.3 because that's angle C on the second triangle, divided by C. Cross multiply. We get C times the sine of 20.5 equals 12 times the sine of 44.3. And so doesn't, oops, wrong color. Doesn't C equal 12 sine of 44.3 divided by sine of 20.5. Wrong color. So C is approximately equal to 12 times the sine of 44.3. If you hit enter, is 8.38 divided by the sine of 20.5. 23.9. So let's check for reasonableness. So let's put these up here. So 23.9. And then on the other one, this was 34.12, or 2, sorry. So if I check for reasonableness, let me see if I can move it over. Yay. Wow. So our smallest angle, is that our smallest side? And our largest angle in this one is the 94.7. Is that our largest side? Seems reasonable. Smallest angle, smallest side. This time, B is our largest angle. Is that our largest side? Yep. So it's reasonable. Any questions? There's 2 solutions to this one. So you end up having to have 12 answers. 3 angles, 3 sides on 2 triangles, right? Right? All right, so, I mean, the 2 solutions ones isn't that much longer. You just have one extra step. Well, you just have one extra step because you have to test the supplement anyway, unless you have no solution. Okay? So,
This is hard.
Yeah.
oh, because I learned a new method that makes it easy. Do you like the new method?
What was the old one?
Yes, there's an, okay. I'm gonna stop the recording just so that you don't hear the old method.